In today's lesson, in this one we're going to finally diverge from multiplication and division. We're going to work on adding and subtracting radicals. Now this is a little bit different, okay? So the first thing you're going to do is simplify the radicals first. Simplify if possible, and then you have to see. You can only add or subtract them if you have like radicals. What that means is if you have the same number inside the radicals. That's the only way you can actually combine them if you're trying to add and subtract. So let me show you what this looks like. So the very basics are when you can't simplify first, okay? So that's what I'm calling the basic case. If they don't simplify, you just have them. So 2 square roots of 5 plus 7 square roots of 5. So if I have 2 of them here and 7 of them here, the same number inside the radical, that's just going to leave me with 5, or with 9 of those square roots of 5. If I have 3 square roots of 10 and I'm subtracting off 7 square roots of 10, again, the big idea is both have the same number inside the radical, both are square roots of 10. So if I'm starting with 3 and I'm subtracting 7 off, 3 minus 7 is minus 4 of those square root of 10s. So make sure when you add and subtract, make sure you're not changing that number inside the radical. That number doesn't change. All you do is add or subtract on the outside. Now, of course, in true cases, sometimes we're going to have to simplify first. All right, so in simplifying first, what I mean is that square root of 20, well, you need to see what can pull out of that. What perfect square pulls out? Well, hopefully, if you look at your powers chart in the second column, you can see 4 pulls out. 20 is 4 times 5. So hopefully you know that that is how that is going to split up. 4, well, the square root of 4, the reason we pulled it out is the square root of 4 is just 2. Now that I've done that, now you can see I have the same number inside the radical, both are 5s. So now all I have to do is 2 of them plus 2 more of them is going to give me 4 of them. So 4 square roots of 5. And of course, in some cases, you may have to simplify both radicals. So how does the 72 break down? Well, if you look at your perfect square chart, you can see 72 breaks down into 36 times 2. You can see 18 breaks down into 9 times 2. So that chart is still very useful to see what perfect squares end up pulling out. Well, square root of 36 is just 6. Square root of 9 is 3. And hopefully you remember from our previous lessons, now 3 times 6, well, that's just going to be 18. 2 times 3 is just 6. So now, finally, after all that work, now I'm able to say, well, I have 18 square roots of 2, taking off 6 of those square roots of 2. So that leaves me with 12 of the square roots of 2. So sometimes it can get a little bit longer when you have to simplify first, but the end result is still the same, just a little bit longer of a process. And now finally, I do want to show you that sometimes they don't combine at all. Now what I mean by that is square root of 40 splits up into 4 and 10. Okay, 4 is a larger perfect square. Well, 36 is actually already a perfect square. The square root of 36 is just 6. So this one, you get 2 square roots of 10 plus 6. And notice, they don't both have a like radical. So these actually can't combine. So the idea here is don't try to over combine just to get to a single term. Sometimes you can't, and you just have to accept that. Okay? So again, the goal of this one is just to show you, even when you simplify, sometimes they won't be able to combine, and that is okay. Just leave them. You can only add them if they have the same square root number. All right, so thank you for joining me. As always, make sure you have all of it filled out, and then make sure to ask me if you have any additional questions.